Hello, this is Mr. Holly. We'll be looking at Module 3, Lesson 2. To begin our lesson, we are going to have a quick review of additive inverses and opposites. And if you look here at the opening exercise, it gives you an expression and it would like you to write the opposite of the expression. 3, the opposite of 3, or the additive inverse, is negative 3. To prove that they're opposites, well, what do we know about opposites or additive inverses? They create 0. So 3 plus negative 3 would create 0. That's true. Now, the opposite of negative 7 is 7. We prove that because negative 7 plus 7 creates 0. Same here. What's the opposite of negative 1/2? It would be positive 1/2. Negative 1/2 plus positive 1/2 creates 0. If all of this is true, then what would be the opposite of the variable x? So if I have 1x here, because this is x by itself, so I can think about this like it's 1x. What would be the opposite of having 1x? Well, it would be having negative 1x, or removing an x. So I could say that negative x is the opposite of x. So x plus negative x is equal to 0. I can apply that same thought process here. 3x plus a negative 3x is going to get me back to 0. And if we remember back in our additive inverses, we learned that the opposite of a sum is the sum of its opposites, meaning if I take the opposite of two terms inside of a parentheses, it's the same as the sum of taking the opposite of each term. So in this case, I have x plus 3. The opposite of that would just be the opposite of x plus 3. Well, the opposite of this sum is the sum of the opposite of each of these terms. So if I just make each of those terms the opposite, that is the opposite. So let's look at that. If I was to add those together, x plus 3 plus negative x plus negative 3. Does this create 0? Well, x and negative x, that's 0. 3 and negative 3, that's 0. So we are proving that this is the opposite of this. Next, we'll look at 3x minus 7. What is the opposite of 3x minus 7? Well, we should take the opposite of each term. This is minus 7, which is the same as plus negative 7. So the opposite of 3x is negative 3x. And the opposite of negative 7 is a positive 7. Let's add them together. 3x minus 7, or I could rewrite that as plus negative 7, plus negative 3x plus 7. 3x and negative 3x create 0. Negative 7 and 7 create 0. So we have proved how to create additive inverses. And the really important part here is that you are going to be taking the opposite of an expression, like 3x minus 7. We've shown that that's just taking the opposite of each term. One way to think about that as well is to distribute a negative 1. So if I'm taking the opposite of 3x minus 7, I can distribute a negative. So I'm multiplying 3x times negative 1, I'm getting negative 3x. I'm also multiplying minus 7 or plus negative 7 times negative 1 and getting a positive 7. So there's a couple ways to think about that, and that skill is going to be important as we continue. Alright, so now let's actually look at how we would apply that. Here I see some expressions. This is one expression. It is in expanded form, which means it is not simplified. I can look at this, and our goal today is that we want to create equivalent expressions. It's important to remember this idea. This is a fundamental idea that we're going to study all through 7th grade. So I want you to think what we're doing is we're rewriting this so that it looks different, but the value doesn't change. Like, it is worth the exact same thing. It is equivalent. but it's going to be expressed in a different way. So now I could look at this and see 40 plus 9 minus 30 plus 2. Well, we could make this 40 plus 9, and the opposite of 30 plus 2 would be plus negative 30 plus negative 2. And then I could add these using the commutative property. I could do 40 plus negative 30, and I would get 10. And I could do 9 plus negative 2 and get 7. My answer would be 17. And the key concept here, and this is a big deal for you in 7th grade. This is an expression. 17 is an expression. This is an expression. Those two expressions have the same exact value, as does each of the expressions in between them. And that's why we show our work this way, because what we are doing is we are rewriting every time. We're rewriting the expression that is equivalent to the expression above it. So we're just going to continue to write in equivalent expressions until we get to a simplified version. We would call this simplified version standard form, meaning all like terms have been combined, and now we're in standard form. We'll see standard form with a variable in just a minute. All right, now let's look at this problem. 3x plus 5y minus 4 minus the sum of 4x plus 11. So I'm going to go ahead and decompose, or not decompose here, but break this up into terms. I'm rewriting this as addition. 3x plus 5y plus negative 4. I can get rid of the parentheses because once we create addition, it's commutative and it's associative, so the parentheses we can drop those. Now, minus 4x plus 11. So I want to add the opposite of 4x and add the opposite of 11. Now, once I've done this, I need to add the terms that are alike. What this means, a term is alike if it has the same variable. So here, I see a term that has an x variable and another term that has an x variable. I'm going to go ahead and just kind of, as a strategy, put a box around those. And I want to include the sign that comes before it. This is plus negative 4x, so I'm going to put a box around those. Now 5y, it doesn't have any other terms that are alike, so I'm going to leave it as it is. Here I see two constant terms, which means they're just a number, no variable. And I'm going to circle those, plus negative 4 and plus negative 11. This is circling and putting squares around terms is just a strategy so that we can try to identify which ones are alike. 3x plus negative 4x is going to add together. 3 plus negative 4 would be negative 1, so negative x. I'm going to write 5y here. We're just going to bring that down because there's nothing we can add to that. There's nothing alike. There's no other term that shares the y variable. And then I have negative 4 plus negative 11. Negative 4 plus negative 11 is going to be negative 15. Now this is written in standard form, which means all terms have been combined, all like terms. And it's important to note that when we write in standard form, we're going to arrange our exponents in alphabetical order, x, then y, and we would also arrange them by order of, did I say exponents? We're going to arrange our variables in alphabetical order, x and then y. And then we would also arrange them in order of exponents, with the highest exponent coming first. But in 7th grade, we really don't deal with any variables that have any exponents, okay? In the case that you did, like x squared would come first before x. But we don't deal with that in 7th grade. So standard form for us, variables in alphabetical order, constant term comes last. We can make note that is standard form. All right, we should have time to do these bottom two problems. Find the sum by aligning the expression vertically. Okay, so just as we are able to add horizontally, we could also stack these vertically, just like a vertical addition problem. So what I'm going to do is line up my variables, 5a plus 3b, and I actually want to rewrite this as a negative value, plus negative 6c. Everybody's comfortable with minus 6c is the same as adding negative 6c, I hope. And then the sum would be plus 2a minus 4b, so that's plus a negative 4b, plus 13c. Now, we could add this vertically, just like when you do vertical addition, and you just add by the place values. Here we're going to add our variables that have a c. Negative 6 and 13 is 7c, plus 3b and negative 4b would be negative 1b, so I'm just going to put negative b. And 5a plus 2a is going to be 3a. 3a plus negative b plus 7c, and that is standard form. That's as simple as we can get. We cannot add a and b together or b and c together. We can't add those terms together. Okay, look at D. It says we are doing 2x plus 3y minus 4. So I'm going to write that as plus negative 4. And we are subtracting 5x plus 2. So I want to write that as plus negative 5x plus, there's no y term here. And I'm going to line this up over here. That should be, so we're subtracting 2, we're going to say negative 2. So 5x plus negative 2. All right, negative 4 plus negative 2, that is going to be a negative 6. 3y does not have a like term to be added to it, so we're just going to bring 3y down. 2x plus negative 5x is negative 3x. So here I have negative 3x plus 3y plus negative 6. Variables are in alphabetical order. Constant is the last term. That's in standard form. And that's perfect. Okay. We could actually switch over to your vocabulary at this point, and I'm going to provide that vocabulary for you right here, and you can pause the video and write it in. But an expression in expanded form is like we began with earlier, where we had something like 3x plus 5y minus 4 minus or plus negative 4x, right? So now I have multiple terms here. These are expanded out, and they could be combined, but they're not necessarily combined at this point. That means it's expanded. The terms, that would be each of these individual pieces. It's each summand of an expression. It's each part that's being added or subtracted. The coefficient would be the numeric factor in the term, or excuse me, the product of the numeric factors in the term. So if I had like 2x times 4, my coefficient would be 8, as in 8x. So 8 would be the coefficient. So what I would do is I would multiply all the factors together of the term. Whatever the numeric factor is, that's my coefficient. You can also just say it's the number that comes before the variable. And then expressions in standard form, like I said, that is whenever we go alphabetical order, X, Y, Z, A, B, C. You list your terms in your variable terms in alphabetical order, and your constant term comes last. So if we go back to this expression up here, if I wanted to write that in standard form, I would combine 3x and negative 4x and get negative x plus 5y plus negative 4, and now it's in standard form. All right, let's stop there, and I'll continue the video. We'll do a part 2.